Example 1, testing a hypothesis about a population standard deviation with a left tail test. Now, in example 2 from section 10.3, the quality control engineer for M&M Mars tested whether the mean weight of fun-sized Snickers was 20.1 grams. Now, suppose that the standard deviation of the weight of the candy was 0.75 gram before a machine recalibration. The engineer wanted to know if the recalibration resulted in more consistent weights. Conduct the appropriate test at the significance level alpha is equal to 0.05. The data are reproduced in table 2. So here is our data. Now the approach. If the recalibration results in more consistent weights, then the standard deviation weight should be less than it was prior to recalibration. We want to test if the population standard deviation is less than 0.75 gram. Now, before we can perform the hypothesis test, we have to verify that the data come from a population that is normally distributed by constructing a normal probability plot. And then we're going to follow steps 1 through 5. So let me open up StatCrunch here. So in our StatCrunch, I put in the data here. So here you have Snickers, here's your data. Okay, and then what we want to do is we want to check out the QQ plot. So we'll select Snickers and then hit compute, and we can see that it's approximately normal just by putting this data in, and it's given us probably a linear type of situation. So therefore we know that it's linear. Now, we then need evidence to conclude that the population standard deviation is less than 0.75 gram. Now, this can be written as the population standard deviation less than 0.75. So we have the null hypothesis where the equality is always given. So we know that the standard population standard deviation is equal to 0.75 gram versus the alternative where this is the population standard deviation, which is less than 0.75 gram, which then tells us that it's a left-tailed test. So therefore, this is a left-tailed test. Okay. Now, the one thing you want to be cautious of is that the test statistic requires a variance or a sample variance or a sample a population variance. So be careful if the problem gives a sample standard deviation or a population standard deviation. Now in step 2, we know that the level of significance is alpha, which is equal to 0.05. Now I'm going to go ahead and use the classical approach on this example and then create a separate video for the p-value approach. Now, step 3, the standard deviation of the data in table 2 is 0.6404 grams. So how do we figure that out? Well, if we go back to StatCrunch, okay, we put in our data, and then we go to Stat, and then Summary Stats, and then select Columns. And then we're going to select the column that we want, which is Snickers, and go to Standard Deviation, select Compute, and then we can see what our standard deviation is, and you can see it's back here in this figure. So now we're going to use the formula for the test statistic. We're going to take n minus 1 times the standard deviation, sample standard deviation squared, over the population standard deviation squared. So we have 11 minus 1 times 0.6404 squared over 0.75 squared, which gives us a test statistic of 7.291. Now, because this is a left-tailed test, we determined that the critical value at the significant level of 0.05 with the degrees of freedom of 11 minus 1, which is 10. So, since we're looking for the left critical value, it's taken 1 minus 0.95. 1 minus 0.05, which becomes 0.95. So, what we're doing is, by looking at the table, we're looking at the area of 0.95 with the degrees of freedom of 10. And so we can see here that our critical value is 3.9 0.7940. Now that we've found the critical value, we can say that because the test statistic of 7.291 is greater than the critical value of 3.940, the quality control engineer does not reject the null hypothesis. And so therefore in step 5, there is not sufficient evidence at the alpha equals 0.05 level of significance to conclude that the standard deviation of the weight of fun-sized Snickers is less than 0.75 gram. It appears that the recalibration did not result in more consistent weights.